All right, so as you can see, the majority of these problems are thankfully giving you an example of a picture to use, but here's a situation where they don't. But that's okay, we can draw our own picture. A couple of things we probably want to focus on. Let's all read the question. A 30-foot ladder leans against a house. It touches the house at the top of the exterior wall. The exterior wall is 23 feet high. What is the distance from the foot of the ladder to the bottom of the house? So let's just underline a few things. We need to make sure we know we've got a 30-foot ladder. We've got the exterior wall is 23 feet high, and we're looking for, let's see here, the distance, foot of the ladder to the bottom of the house. So just kind of making sure we know where it is we're going. Now let's draw a picture. And I mean, this does not have to be pretty. In fact, mine will not be pretty. Let's see here. Let me make a house over here. And he's just got a flat top roof. It says a 30-foot ladder leans against a house. It touches the house at the top of the exterior wall. So here's my ladder. And they told me that ladder was 30 feet high. So we'll put a 30 over here. And the exterior wall is this wall right here. They tell me it's 23 feet. And then let's extend our line to make ourselves a pretty triangle. It says we're looking for the distance from the foot of the ladder. Well, here's the foot of the ladder in case you weren't sure what that is. That's actually at the bottom to the bottom of the house. So this purple line is what we are trying to find. So we're going to put an X here. Now, the goal is to recognize that in the real world, ideally, the contractor has made an exact 90-degree angle with the ground. And so we've got ourselves a right triangle in theory that pops out. So we've got two sides. We're looking for a missing side. This immediately you need to know is we're using our fabulous tool, the Pythagorean theorem. We'll call this our C, we'll call this our A, we'll call this our B. So C squared equals A squared plus B squared. So go ahead and pause the video and let's figure out what X is when you have finished doing the work. Restart the video and check your answer. All right, and you should have gotten that X is equal to 19.3. If you didn't for some reason, please raise your hand and we will be glad to give you some assistance. All right, next one we've got is this example. We've got a kite on a 25-foot string, makes an angle of 40 degrees with the ground. How high above the ground is the kite? So they were kind enough here to give us a triangle to use. Let's all make sure we put the information we're looking for on the picture, because without it, we can't really figure out what sides are important to us as we begin to do some marking. They've given us the fact that it's 25 feet, the kite. The angle's already been set here, and we're looking for how high the kite is above the ground. We're assuming the ground is here, so this is the side we are looking for. So I'm going to put an X over there. So there we go. All right, so let's begin our marking. I'm going to circle my angle. That's important to me. I can see the hypotenuse is opposite my right angle, so I put an H here. And obviously in this case, I'm marking my sides and so forth because I don't have any information right here, so I can't use Pythagorean theorem. At this point, I've got to go to trig. In fact, as Ms. Thompson points out, if you circle the angle, you're probably going to need to be using trig at that point in some figure. So anyway, it's a 40-degree angle. We're going opposite it. To find our opposite side, we've got this side over here is our adjacent side because we know that side is attached, right, to the angle. That side's right there. But we don't really need him anyway. We can kind of kick him to the curb if he's bothering us. The two sides that are important, again, using our SOH, CA, TOA. The two sides that are important to us are the O and the H. So we should be using the sine function to solve for X. I'm going to have you guys go ahead and set up the equation and solve for X. If you could please pause the video and take an opportunity to do the work, and then return on the video and check your work from there. All right, and you should have gotten that x is equal to 16.1, just to kind of make sure we all see what's happening in this step. I'm just doing the setup. Sine of 40 is equal to opposite over hypotenuse. In this step, I've done the sine of 40, and then finally here, I'm cross multiplying. So x times 1 equals x, and 0.6428 times 25 is equal to 16.1. And so we've got our solving for x in that situation. 99% of the time, the SOL has been giving pictures to use, but you still have to know how to apply them. And I know sometimes the words get in the way, such as in the example we started with. All right, the last one here. This is what we call a 30, 60, 90 triangle, and it says the length of the side opposite the 30-degree angle is 8.3 centimeters. How long is the side opposite the 60-degree angle? Round your answer to the nearest tenth. Well, first and foremost, we need to understand what we have been given and where it is on this picture. It says the side opposite the 30-degree angle is 8.3 centimeters. But if I look at my picture, I've got a 60-degree angle here. Of course, we've got a 90-degree angle here. And the question is, well, where's that 30-degree angle? Remember, the sum of the angles in any triangle is 180. So take away the 90, take away the 60, and oh yeah, looks like this other angle is going to be 30 degrees. Now I'm going to put both of them in there, and this might bother some students because at this point the question might be, what angle might I be circling if I need to circle an angle? But let's talk about it when we get to that point. It says how long, by the way, the 30-degree angle is here, so the side opposite it, they said, which would be the guy, if I was sitting in the corner walking opposite, would be 8.3. So I'm going to mark that 8.3. And the question is, how long is the side opposite the 60-degree angle? Well, here's the 60-degree angle. And opposite him, again, if I'm walking from the inside, is going to be right here. So I'm going to put an X there. And then I'm going to erase some of my trash going on here. All right, that 60 pops back out. So now we have everything we need to solve for X, but the question is, which angle do we circle? Well, guys, it doesn't matter. Either of these angles could be used using trigonometry to solve for X. In fact, what I'm going to ask you to do is you choose whichever one you like the best. It really won't matter, but you must commit to either the 30-degree or the 60-degree angle. And then what I'm going to have you do is do the solving, tell me what you get for X. When you open it back up, I'm going to show you both ways you could have come up with the answer for X, depending on which of the two angles you chose to commit to as you do your circling. So just circle one of the two and then mark your sides just like we've done for the other problems for opposite, hypotenuse, and adjacent. And then turn it back on and see what you got. Okay, so you can see I have kind of laid this out, and I've done it by color. On the left-hand side, over here in blue, we've got this triangle where I pretty much left off the 30-degree angle to show you what it would look like if you chose the 60-degree angle to circle and mark. And then I walked myself through the tangent of 60 in this case is equal to, again, the opposite over adjacent. And then I walk myself through the problem and I get X is equal to 14.4. Over here, I've got the red side of the world, and I've got this red triangle. Again, I just redrew it to put the 30-degree angle alone. And when you see what's happening is the O and the A have flopped spots. In this case, I'm using the tangent of 30, and I'm also using two different things, meaning I've flipped them around because my O and my A have also flipped around. But when it's all said and done, my answer, X is equal to 14.4, is still the same thing. So we don't care which one you choose, but you have to commit to it and mark it correctly. All right, finally, there's a little summary here, and I know this isn't something that I often do, but I would like for you, however you want to write this out, Final thoughts. When do you use Pythagorean theorem? When do you use trigonometric ratios? What does SOHCAHTOA mean? I don't really care how you write this. It can be a sentence. Sentence, that's how you spell that. You can do a drawing of a right triangle, but give me at least a little love on all three of these scenarios somehow, some way in the space down here, okay? I'm just asking you to make an effort. And this will be something that I look at every single notebook to make sure that you guys made the effort to do that. And then when you are finished, you can go ahead and grab a copy of the homework and begin.